Hello everyone, I'm Karan Anand, a final year student of BTech CAC batch from Bennett University, and here I am to present my research on deep learning compression techniques through magnitude-based weight pruning and filter pruning. First of all, I'd like to thank Dr. Deepak Garg, HOD of my CSE department, for his immense support. I would like to thank Dr. Anurag Goswami and Mr. Teja Lal Chaudhary for their immense support. I am very grateful to my friends and family for their unconditional support throughout the project. Deep learning models can have millions of nodes which consumes a lot of size and memory and processing power. Training and retraining them consume a huge amount of energy, but not all the nodes in the deep learning model are equally important. Hence, pronings come into play. Pruning is one of the most popular techniques through which a deep learning model can be compressed. Keeping the important nodes and eliminating the non-important nodes is really important in today's world because we need to use efficient, cost and time-consuming technology. A deep learning model have millions of unrelated parameters. Hence, it's very necessary when there are limited resources to eliminate the non-important nodes. The whole purpose of doing and using the pruning techniques is to reduce the MAC operations, which leads to the accuracy of the model. Removal of those parameters would least affect the accuracy of the network. In return, we also get to reproduce a small size model with better efficiency, as the main motive is to reduce the DL model, which makes it storage friendly. There are many applications which require on-demand human-like decision-making abilities. For example, a driverless car, which is being so much popular these days, which must detect various objects on the road on a real-time basis, such as humans, animals, walls, or railings, and other cars also, by calculating the distance of them from the car so that the car can take action such as turn, stop, or move forward. Hence, this process must be fast enough, as all of those being done in real-time basis, and delay in processing such distances can lead to dangerous accidents. Hence, it's very necessary to reduce the size of the trained model before implementing it into the resource-limited devices, which cannot compromise on efficiency. For successful completion of my project, I did various research in the field of deep learning compression techniques. Some of the compression techniques which were recently announced and released were magnitude-based pruning. In magnitude-based weight pruning, weight are considered as the most important parameters, and nodes elimination depends on the weight carried by them. We prune the weights by making them zero if they are less than or equal to the threshold value, and it does not get copied into the new model which we have created. Another model was L1 norm filter-based pruning. A certain amount of filter is pruned out in each layer in the CNN network and were copied to a new CNN network which was retrained for the result. The method was using absolute sum for them to find out which is the most important filter in the network, and used to make them in a ascending order or descending order and prune out the asked number of filters from it. Another pruning technique which I studied was TNet. TNet is a type of method in which the prune channel has the least effect on the next layer of the network. It uses the activation function as for its calculation. It minimizes the chances of error, as pruning is done by keeping in mind what will be the effect of it in the next layer. Another pruning technique I studied was network slimming structured pruning. It was an advanced study for the L1 norm filter-based pruning which I did. It imposes L1 sparsity for the channel-wise factors from the normalization of batch layers during training. It prunes channels with the lower factor as it comes over all the layers, hence it automatically detects and prunes channel across the whole network. I went also through a technique known as partial clustering of filter pruning. It uses cosine similarity matrix for choosing the channels and pruning them out. Hence, it uses the equilibrium distance vectors, as there are several attributes for calculation which makes cosine distance perfect for deep learning neural network. the most easiest technique I came through was the random pruning. In random pruning, randomly a set of nodes, filters or channels are eliminated or pruned out from each layer and does not keep in mind what will be if its effects in any way. It does not use any calculation, any method, it just prunes any random number of parameter asked. Hence, it reduces the size of the network but it spoils the accuracy of the model. I used Cypher 10 and Cypher 100 as my dataset. Cypher is a dataset in which there are 60,000 color images of 32 by 32 size, in which 5 sets of training batch are created consisting of 10,000 images each, and one testing batch is created which consists exactly of 10,000 images. I used VGG as my model which has up to 19 layers. There is a very simple pipeline for pruning techniques of training a small model from scratch to pruning it to refining it. When a model architecture is predefined manually, you can say, we usually consider a common ratio of channels to prune in each layer. For example, we want to prune 50% of the filters or channels in each layer of VGG. Unstructured pruning also follows automatic methods where the position of weights with the least important is identified by training process and the algorithm. It is generally not possible to manually decide the position of null values before initializing of the training process. As you can see in the below diagram, you can see that there is a simple structure to it. Train the model, prune it, then retune it, and then you can store your results in any format. I also proposed a new hybrid technique. As you can see the diagram below, it's flowchart of this hybrid form only. This hybrid form is a mixture of two different existing deep learning model techniques, which consist of the L1 norm pruning technique and the magnitude based weight pruning technique. The VGG16 model was trained through the Cypher 10 dataset, and the VGG16 model was trained through the Cypher 10 dataset, and then we used L1 norm pruning method at a 50% pruning percentage. The L1 norm is a filter-based pruning technique that uses absolute sum to find out the least important filters and channel in each layer and eliminate them. Then the pruned model was transferred to the weight-based pruning method at 30% tuning efficiency, then simply retrained using the same dataset as to get a test accuracy of 92.8%, as nearly similar to the test accuracy of 93.3% when the model was greater in size and uses more resources. Many other hybrid possibilities were also experimented, but they failed due to some architectural structural issues. L1 norm technology and network slimming technology are not compatible, as network slimming uses a batch norm parameter which is not suited to L1 norm parameter. We used and experimented these two pruning techniques as to find a solution for hybrid. As we can see the results table, we can clearly see that network slimming and the proposed hybrid pruning method have the best percentage. Hence, they should be considered. Many challenges were faced during the completion of this project. Due to limited availability of the resources, it was very difficult to complete this project. Significant amount of time was spent in understanding the behavior of DL models and compression techniques, which was very time consuming. The deep learning model needs heavy processing power as it is dealing with heavy training, testing of heavy deep learning models. Even on DGX, model training, pruning and retraining was a long process, hence it takes a lot of time. In relation of the new hybrid technique, there were many compatibility issues as different models have their own nature, and hence I faced some configuration issues. There were many things I learned by doing this project. I had hands-on experience on DGX which was new to me, hence exposure to various deep learning models like ResNet, VGG16 were another advantage by doing this project. I also used Cypher 10 and 100 and ImageNet, which were one of the most famous datasets available on the internet. I also got exposed to many pruning techniques such as magnet pruning, filter pruning, which can be very useful in future. The objective of this project was to study deep learning model compression techniques and to compare and find the best technique which gives good result. The results from the comparison of several different techniques indicated that every pruning technique is unique in its own way and have merits and demerits of its own. Still, I would like to conclude that for a structured model, network slimming was and the proposed hybrid form can be used, and for the unstructured model, weight pruning technique should be considered. A new technique was also discovered for compression. This hybrid form shows a significant improvement in the field as it opened doors for improvement in getting relatively high accuracy of 92.8%, even when pruning ratio is as high as 80%. Future aim would be to study a few more papers and try to find a better alternative or method as to achieve better results and hope to learn more things. More testing can be done, which can lead to a new hybrid form and lead to innovation in the field of deep learning and artificial intelligence. Thank you.